Hello, a very good afternoon to everybody there. We are going to continue from where we stopped previously. So for semester 1, we are going to start a brand new chapter, which is about kinetic chemistry. So before we begin our lesson, if you like my videos, please give a like to the videos. And if you want to receive the latest information, please subscribe to my channel so that you can receive the latest information. So without any session, let's begin our lesson, shall we? So we are going to start on with the discussion for the objective questions. So let's begin. Number 1, decomposition of phosphorus pentachloride is shown according to the equation below. The reaction is first order with respect to phosphorus pentachloride. Which of the following graph is a graph of negative dPcl5 dt against PCl5? So generally, negative dPcl5 dt is actually red. It's actually red. So what is the graph when red against concentration for the first order reactions? So the graph of the you link with this equation rate equals to Ka. So when rate equals to Ka, so supposedly it is a positive gradient. Okay, so therefore the best answer in here is C. Then number 2, when a positive catalyst used in the reaction, which of the following statement describe the situation which occur? Number 1, forward reaction increase while the reverse reaction is retarded, which is not true. So because when you using catalyst, it lower the activation energy, both forward and backward reaction rate will also increase. So A is wrong. So the activation energy of the reverse reaction is also reverse. D is also wrong. Then the enthalpy change of the reaction become more exothermic. So adding catalyst will only speed up the reaction but will not affect the enthalpy change. So B also wrong. So number C, it does not affect the final equilibrium, which is the amount of the reactant and product, which is correct. Okay, so the best answer in here is C. Number 3, if a reaction involving a single reactant is first order with the rate constant 4.5 times 10 power negative 2 second minus 1, how much time is required for 75% of initial concentration for the reaction to use up? So in here, you can use the half-life equation. T half is equals to 0.693 over K. And then your T half is 15.4. So to decrease the concentration by 75%, that means the remaining is 25. So for the remaining 25, you have to undergo 2 half-life. If you don't understand, probably it will look like this. Excuse me. So the first T half, originally you have 100%. Okay. So after first T half, you get 50%. Okay. After the second T half, you get 25%. So that is what it means by 75 of the initial concentration reaction is used up. So you undergoes 2 half-life in here. So when it undergoes 2 half-life, so it's 30.8 seconds in here. Okay. So the best answer in here is B. Okay, so that is how you answer for number 3. And then for number 4, which of the following statement regards the half-life of a first order reaction for a single gaseous reactant is true? A, half-life is affected by pressure and the volume of gas, which is incorrect because half-life is only affected by the rate constant. Number B, half-life depends on the concentration, which is also incorrect. As I mentioned just now, also depend on the temperature. Half-life is longer at a lower temperature, which is true because when you have a lower temperature, rate constant also decrease, therefore half-life become longer. And finally D, after 3 half-life, concentration of the reactant decreased by 75%, which is wrong. So after 3 half-life, you decrease by 87.5%. So the final concentration will be 12.5%. Okay, so the best answer in here is C. 5. The rate equation for the reaction 2QO2 plus Cl2 give 2QOCl2 plus O2 is given below. Rate is equals to KQOCl2 and Cl2. Which of the following mechanism consistent with the rate equation? So in here, when you show the mechanism, so you must look for the slow step, which has this bimolecular for QO and unimolecular for Cl. Okay, so if you look at A slow step is only contain 2 QO2, so A is wrong. B, slow step contain 1 QO2 and 1 Cl2, which is also not our choice of answer. As for C, in here you have QOCl, QO2, and Cl in the slow step. So C is not in our answer selection. And then for D, it is a QO plus Cl2 to give QOCl. Okay, no answer in here. Sorry, because I think I accidentally typed wrongly. Yeah, yeah, correct. QO square, sorry. So QO square times Cl2. So QO is bimolecular, Cl2 is unimolecular. So the best answer is donkey D. Okay, so that is for number 5. Then number 6, for the reaction 2XO plus O2 give 2XO2, some data obtained for the measurement of the initial rate is given below. So what is the rate equation? Now, if you study carefully, you understand that for the experiment 2 and 1, doubling the concentration of O2 will double the initial rate. So this will mean that O2 is first order. Whereas compare experiment 2 and 3, if the concentration increased by 3 times, initial rate increased by 9 times. Okay, so in another word, the initial rates in here when increased by 9 times, when the concentration increased by 3 times, so that means that XO is the second order. Okay, so therefore XO is second order, O2 is first order. The best rate equation in here will be A. Okay. Number 7, energy profile for the reaction between NO and O2 is given below. So 2NO plus O2 gives 2NO2. Which of the statements are true regarding to the reaction? Number 1, reaction occur is an exothermic process where you have E2 minus E1, which is correct. Okay. Then number 2, activation energy for the forward reaction for an uncatalyzed reaction can be calculated by E3 minus E2. So no, it's E3 minus E1. So B, number 2 is incorrect. Number 3, catalyzed reaction involve a lower activation energy via a 2-step reaction. So in here you can see that you have 2 loops in here. So when you have 2 loops, it involves 2 steps. So number 3 is correct. And number 4, rate equation for the uncatalyzed can be written as a KNO2 times O2, which is correct. Why? Because this is a single step reaction. So in the single step reaction, so 2NO plus O2 will be the rate determining steps. So number 4 is also true. So the best answer in here is 1, 3, and 4. Then we have a look at number 8. The distribution of the molecular kinetic energy at 273 Kelvin and 283 Kelvin shown in the normal distribution graph below. Which of the following statement best explain the rate of reaction in the gas at 273 increased by 2-fold when temperature increased to 283 Kelvin? Number 1, number of particles increase? No, the number of particles is still remain the same. Because they have the same area, so A is wrong. B, effective collision at 283 is twice higher, which is correct, because when you have a broader area, that means you have more particles has energy greater than activation energy, therefore the effective collision is effective. C, molecular speed increase at a higher temperature, so it seems that molecular speed generally increase, yes, but that does not explain why does the reaction rate increase by double. Okay, so C is compared to B, C is less accurate. And then D, activation energy increased by twice. So it's not activation energy. Activation energy is still remain the same. It's just that particles that have energy greater than any activation energy is greater. So that is why statement D is also wrong. Okay. So that is how you explain the statement. So the best answer in here is boy B. Number 9, reaction between G and H to produce J and L was carried out at 2 different temperatures as the results shown below. So you have a concentration of G in excess of H plus, so G decreased by like this, and then concentration of H increased by like this. So if you study carefully, okay, so I'm going to draw out the graph for you. So initial concentration 1.5, half-life is 75. So this is you have like 10 minutes, and then the other half-life after 0.75 is 0.325. So 0.325 is somewhere here lah. Okay. So the first T half is about 10 minutes. The second T half is about 20 minutes. So it is first order with respect to G. As for H, if you plot the graph of concentration against time is a linear negative gradient, it shows that H is 0 order with respect to the reactions above. So that is why first order for G zero order for H. So the best rate equation shows, excuse me, the best rate equation shows in here will be the best rate equation shows in here will be B, rate equals to Kg. Excuse me. Number 10, which of the following statement about rate constant for chemical reaction is true? So the unit is S-1, which is incorrect. Rate constant varies. Number 2, it does not change if, excuse me, it does not change if catalyst is added, which is wrong because activation energy is influenced by the rate constant. So B is also wrong. It remains constant at a constant temperature, which is true because only temperature can change activation energy. Rate constant, sorry. And then D, excuse me, it decreased as the concentration of the reactant decreased, which is also wrong. So the best answer in here is C. Then we have question number 11. Kinetic data of the reaction A plus 2B gives C at a certain temperature. Excuse me, is shown below. You have the following concentration. Okay, number 11, the kinetic data for reaction A plus 2B gives C at a certain temperature is shown below. So you can see from the tables in here, you have experiment 1, X and Y will give initial rate R. Experiment 2, 2X plus and Y you give for R. And experiment 3, X and 2Y you give R. So from here you can see that changes of the concentration of A by 2 times increase the rate by 4 times. And then changes of concentration of B by 2 times will not influence the rate of reaction. So if you want to solve systematically, so usually we'll advise students to do like this. Rate is equals to K, A power of N, B power of N. So you compare experiment 2 to experiment 1. Therefore, you get the order of the reaction with respect to A is second order, whereas the order of reaction with respect to B is zero order of reaction. So the rate equation is written as rate equals to Ka squared. So the answer is A. Then number 12, decompositional ammonia is to its element on the metal surface at a particular temperature is zero order. Which graph represents the decompositions in here? So in here, when you are about to plot for zero order, our linear graph is given by the graph of concentration against time. So graph of concentration against time supposed to be a negative gradient, but that one is T final minus T initial. But if you look at the graph carefully, now is T initial minus T final. Okay, concentration initial minus concentration final. Okay, so it will give the other Y's, which is the positive gradient. Okay, so that is why the best answer to for this question is B. Okay, whereas 1 over is for second order, and then a log is for first order. Log or log is for first order. Okay, so that is why the graph, the best answer in here is boy B. Number 13, graph of initial rate versus concentration of X plus Y gives Z are shown below. You have rate against concentration for X, rate against concentration of Y. So you use the rate equations. You use the rate equation. So the rate equation in here shows that rate equals to Kx. It means that when it is a positive linear gradient like this, so X is first order with respect to, it is first order with respect to X. And then when it is a parabola, because you can continue, so you see it is a parabola, that tries to tell us that Y is a second order of reaction. Okay, so therefore the rate equation in here is rate equals to Kxy squared. So this will give us the answer for C. Then number 14, rate equation for the reaction X and Y is shown below. Rate is equals to Kxy squared. When 0.2 mole of gas X and 0.1 mole of gas Y are mixed at 2.0 decimeter cube vessel at 300 degrees Celsius, the initial rate is 3.2 times 10 power negative 4 mole per decimeter cube per second. Which of the following statement is true for the reactions above? So at 300 degrees Celsius, so you substitute into the rate equation. So 3.2 times 10 power negative 4 is equals to K 0.20. Because this is mole, you have to be in concentrations. So 0.20 divided by 2, multiplied by 0.1 divided by 2 square. So you get your rate constant is equals to 1.26 times 10 power times 6. Then mole minus 2s minus 1. However, when the volume becomes 4.0, so the rate equation, you can see for that, it will become 1.8 times 10 power 3.2 times 10 to the negative 4, which is 1/8 times of the original rate. Whereas the rate determining step depends on the 1 molecule of X and 2 molecule of Y. So that's why the rate determining step is bimolecular. Okay, so in here, the correct answer is A. Sorry for the mistake just now. It is not bimolecular, it is trimolecular. Sorry for that. So the best answer in here is A because it lower by 8 times, lower by 8 times of the rate equation. Sorry for that. Okay, so that is for number 14. Number 15, hydrogen peroxide and iodine react in the following reactions. So H2O2 plus 2I minus plus 2H plus give 2H2O plus I2. The rate equation for this rate equation for the reaction can be represented by rate equals to K H2O2 power of P, I minus power of Q, H plus power of R. In the kinetic experiment for the reaction above, the graph are obtained. So what is the order of reaction with respect to H2O2, I minus, and H plus? Okay, let's start from the H plus. If the graph of concentration against time is a negative linear in here, H will be 0 order. Then if you look at the concentration of I minus, I'm going to show you. Okay, so the half-life 0.5 in here, if you notice carefully, it is 2,500 seconds. And then the second half-life will be 0.25. Will be somewhere around this, sorry, 0.5 is here. 0.25 will be somewhere around here. Yeah, okay. So 0.25 is here. Okay. Okay. Okay, will be somewhere around here, isn't it? So it's 5,000 seconds. So that is why it is first order with respect to I minus. As for H2O2, if you look carefully, the time in here is 1,250 seconds, whereas the second half-life is 5,000. Okay, second half-life is 5,000. Am I right? No, okay, wait. Here. So second half-life is here, which is approximately 2,600. Okay, so in here, you can see from the graph in here, both X and Y are first order. Okay, both X and Y is first order. Okay, sorry, both I minus and H2O2 is first order. So that is why 0 order for H plus, first order for I minus, second order also for first order also for H2O2. So the best answer in here will be C. B, sorry, B. Okay, because I cannot see the down there. Okay, B. Okay, so that is for number 15. Number 16, the rate constant for the reaction CH3CO CH3 plus H2O gives CH3COH plus CH3OH at 25 degrees Celsius is 6.09 times 10 to the power of 5 second minus 1. What is the half-life of the reaction? So in here, you can straight away use T half is equals to 0.693 over K. How do I know that it is first order? You look at the rate constant is second minus 1. So it is first order of reactions. Okay, so so using the formula 0.6, T half is equals to 0.693 divided by 6.9 times 10 to the power of 5. So it's 11,379 seconds or 190 minutes. So the best answer in here is B. Okay, number 17. The reaction of iodine with propanol in the aqueous solution is acid catalyzed. It is the first order with respect to the concentration of hydrogen ion and the concentration of propanol. Which statement is true of the reaction? Number 1, unit of the rate constant is decimeter cube mole minus 1 S minus 1, which is correct because they are both first order. So it is a second order overall. So you have mole minus 1 dm cube S minus 1. 1 is correct. And then number 2, rate of reaction at pH 1 is 10 times faster than at pH 2, which is also correct because pH 1 is 0.1, pH 2 is 0.01. So the concentration is 10 times greater. So 10 times slower, not 10 times greater, 10 times slower. And 10 times faster. So number 2 is correct. Number 2 is correct. Okay, number 2 is correct. Sorry, I didn't highlight. Okay, number 2 is correct. So rate determining steps involved between iodine and propanone, which is also correct. And the initial rate of reaction is double as the temperature increase from 25 degrees Celsius to 30 degrees Celsius. So 3 is wrong. 3 is wrong. 3 is wrong. So 1, 2, and 4. Sorry, allow me to repeat question number 17 because I made some mistake on the highlighting. Okay, so unit of the rate constants is, because overall order is second order, so the unit of the rate constant is mole minus 1 dm cube s minus 1. So number 1 is correct. So for the second one, rate of reaction at pH 1 is 10 times faster than pH 2, which is correct because concentration is 10 times greater. So that is why the rate of reaction is also 10 times faster for the H+. Number 3, rate determining step involve the reaction between iodine and propanone is wrong because in here, the first order with respect to concentration of hydrogen ion and propanone only, while iodine is not mentioned, so iodine is probably 0 order. So number 3 is wrong. And then number 4, initial rate of reaction is double as the temperature increase from 25 to 35, which is also correct because for room temperature pressure, increase the temperature by 10 degrees Celsius will double the rate reaction. Okay, so the best answer in here is C. So that is for number 17. Huh? Okay, then we have number 18. The reaction between MnO4 minus and C2O4 minus catalyzed by Mn2 plus produced through the reaction stated. So C2O4 are titrated with MnO4 minus, which graph represent the variation of the rate of reaction. Now, this is what we so-called as an autocatalysis. Autocatalysis. Okay, so the reaction between MnO4 and C2O4 minus, later I'll write on for you. How is the rate of reaction? So initially, when you have little concentration of the MnO4, rate of reaction is low. Okay, so as the number of Mn2 plus produced is greater, then your rate of reaction become higher until when the reaction is almost ended, the concentration of the reactant decreased. So that is why the rate slowly decreased back. So this description best fits as for number D. Okay, so this is what happened when you have autocatalysis reactions. Okay, so that is for number 18. Then number 19, aqueous potassium iodide react with aqueous hydrogen hydroxide in acidic solution according to the following mechanism. H2O2 plus I minus give H2O plus IO, which is slow. H plus plus IO give HOI fast. H plus plus I minus plus HOI is I2 plus H2O, which is also fast. Which statement is true for the reaction involved? A, the reaction involved the transfer of electron from H2O2 to I minus. So in here, the slow step shows H2O2 is reduced while I minus is oxidized. Therefore, the reaction, there is an electron transfer from I minus to H2O2. Okay, so number 1 is correct. Number 1 is true. Sorry, number 1 is wrong because oxidized, that means you donate electrons. So number 1 is the otherwise, is I minus to H2O2. So 1 is A is wrong. And then B, reaction involve acid as a catalyst. So acidic in here act as a catalyst, which is also wrong because hydrogen ion is directly involved in the reactions. Therefore, H plus is not catalyst. And then C, the reaction is second order with respect to I minus, which is also wrong from the rate determining steps. You can see here, you have 1 I minus, so it's first order. So C is also wrong. And the overall reaction is reversible, which is true. Why? Because when you have a reaction with multiple steps, it is almost impossible to be reversed back again. Okay, so that is why the best answer here is donkey D. For number 20, rate constant of a reaction is 6.93 times 10 power -3 second minus 1. Which statement about the reaction is not true? Number 1, half-life of the reaction is 100 seconds. So if you use the equation, T half is equals to 0.693 divided by 6.93 times 10 power -3 is 100 seconds. So A is correct. B, rate of reaction is 6.93 times 10 power 4 mole per decimeter cube as the concentration is 0.1. So you can use rate equals to K 0.18. So after you calculate, you get 6.93 times 10 power -4 mole per decimeter cube per second. So B is also correct. So C, activation energy of reaction is low. Activation energy is considered relatively high because the rate constant is lower. So the reaction is first order with respect to here. So the best answer in here is C. Okay. Okay, so that is for number 20. Then we have 21. The reaction X plus Y gives Z is first order with respect to X and zero order with respect to Y. Rate constant of a reaction is double with an increase in temperature by 10 degrees Celsius. Which set of conditions give the lowest rate of reaction? So in here, I will do the mathematics for you to see what are the reactions that give. So since rate is equals to Kx, an increase in 10 degrees Celsius increase twice of the rate of reaction. So using 0.1 as a standard concentration, so therefore rate equation R is equals to K 0.1x at 10 degrees Celsius. Okay, so that is the baseline. Okay, so we have a look at A, B, C, and D. So for A, rate is equals to K 0.1x times 2 times 2 times 2. Why times 2 times 2 times 2? Because you are increasing 30 degrees Celsius from 10 degrees Celsius. So you increase by 3 times. So the rate will become 8 times greater. Okay. As for B, rate is equals to 0.2x because in here Y is not influenced, so Y we don't consider at all. So 0.2x times 2 times 2. Why? Because temperature increased by 30 degrees Celsius, so you double the rate of reaction. Okay, so rate is equals to 4 times 2 times K, so you also got 8R. Then as for C, you have K equals to 0.3 times 2, okay, because you increase by 10 degrees Celsius. So rate is equals to 3 times 2 times K 0.1x, which is 6 times greater. And then as for D, rate is equals to 0.4x, therefore rate is equals to 4 times K 0.x, so increase by 4 times only. Therefore, it's the lowest among the choice. So the best answer in here is donkey D. So that is how we are going to compare for such type of questions. Okay. Okay, then we have 22. Rate equation for the reaction between X and Y is as follows. Rate is equals to Kxy squared. When 0.2 mole of gas X and 0.1 mole of gas Y are mixed in 2 decimeter cube vessel at 300 degrees Celsius, initial rate is 3.2 times 10 power -4 mole per decimeter cube. Which statement is or are true for the reactions? So since rate is equals to Kxy squared, so when you substitute 3.2 times 10 power -4 equals to K 0.2 divided by 2. So K is 1.28 times decimeter power of 6 mole minus 2s minus 1. So it is correct. Number 2, the unit of the K is the unit in here, so 2 also correct. Rate of reaction is 8 times lower at 4.0 decimeter cube. So when the volume is double, the pressure is half. So rate is equals to K half X and half Y squared, so simply 1/8 rate. So therefore, it is 8 times lower, which is number 3 is correct. And number 4, overall reaction is second order, which is wrong because overall order of reaction is third order. So the answer in here is 1, 2, and 3 correct. Then we go for question 23. In a reversible reactions given to you, dinitrogen nitrogen dioxide give dinitrogen tetroxide. Which of the following statement is true? A, the order of reaction is second order with respect to NO2 gas, which is true because it is reversible, so therefore it is 1 step only. Okay, and then B, rate equation can be written as rate KNO2 power of X where the order of reaction is unknown, which is wrong. Okay, because we can already straight away determine the order of reaction. And then C, initial color of the flask is colorless. However, when the flask is filled with yellow color at equilibrium after some time, no, NO2 is yellow color or brown color to be more exact. And then D, the rate of reaction increased by double if the gas mixture is heated from 40 degrees Celsius to 80, which is wrong. So from 40, 50, yes, but not from 40, 80. Okay, so the best answer in here is A. Then we go to 24. The reaction has the rate law. Rate is equal to KAB squared. Which of the following will cause the greatest increase in the rate of reaction? A. Increase the temperature by 10 degrees Celsius by without changing the concentration. So you have increase. So the increase will increase by 2 times. So therefore 2x. Doubling the concentration of A and B. So you have 2A times 2B squared. So you increase by 8 times. Okay, so that is for B. And then C, tripling the concentration of the B. So you got 3B. So 3B squared will give you 9x. Okay. So will give you 9 times. So that is for C. And then quadrupling the concentration of A. So you got 4A. So increase in 4A will increase the rate of reaction by 4 times only. Okay. So the best in here will be C. Okay, so that is for 24. Then we go to 25. Chemical equation for the reaction is given below. A plus 2B gives C. Given this data in the study of how the rate of reaction was affected by concentration, what is the rate constant for the reaction? Okay, so in here you can use the methods that I showed you earlier. Okay, so doubling the concentration of A will increase the rate of reaction by 4 times. Therefore, A is second order. So you can see from the comparison between experiment 2 and experiment, you can see from the concentration with experiment 3 and 1. Okay, so 0.40, 0.20, so you increase the rate by 4 times, so A is second order. And then for B, increase the concentration by 4 times, you compare experiment 2 to experiment 1. You increase the concentration of B by 4 times, we increase the rate also by 4 times, okay? So the rate is first order. As for C, will it affect the rate of reaction? C will not affect the rate of reaction because C is the product of the reaction. So we do not look at C. Okay, so if you substitute, what is the rate constant? So rate is equals to Ka squared B. So you take any experiment. Let's say we take experiment A. So 0.080 equals to K 0.20 squared times 0.10 squared. So rate constant K is 2.0 moles minus 2 dm 6s minus 1. So the best answer in here is C. So that is for 25. Then we go for 26. Rate constant of a first order decompose is 0.0111 minute. What is the half-life of the reaction? So you use T half is equals to 0.693 divided by 0.0111. You get T half is equals to 62.4 minutes. This is a very straightforward question. So that is for 26. And then for 27, the reaction between X give Y plus Z has the rate equation written as below. Rate is equals to Kx. If we take 80 seconds for 70% of 10 gram sample to be transformed into product, what is the value of the rate constant in here? Okay, so in here you use the first order equation, ln AT is equals to negative KT plus half ln A naught. So you substitute ln 7.0. How do you know that 7.0? So in here they say that 70% of 10 gram is transformed into the product. So that means the concentration of, in terms of gram of the reactant is 70% decreased. Okay, then you take 80 seconds okay, so you substitute all straight away. So ln 7.0 minus K times 80 plus ln times 10, so you get K is equals to 0.45. So the best answer in here is A. Excuse me. Then we have 28. Decomposition of hydrogen iodide at a constant temperature 200 degrees Celsius is second order reaction. Which of the following graph shows the correct for decomposition of hydrogen iodide? So if you plot the graph of 1 over hydrogen against time, it should be a positive gradient. So this is a very straightforward reaction. So the answer is donkey D. Then we have 29. Equation below shows the reaction between acidified potassium iodide and hydrogen peroxide. So you have 2I minus plus H2O2 plus 2H plus give I2 plus 2H2O. Reaction involved in the following stage. There is step 1, step 2, and step 3 as shown in here. Number 29. Which of the following conclusion can be drawn from this information? A. The acid is a catalyst. No, in here acid does not act as a catalyst because acid react directly involved in the reactions. So number 1 is incorrect. Number 2, reaction is first order with respect to iodine ion, which is true because I minus is in rate determining step, so it is first order. So the rate determining step is H2O2 plus I minus give H2O plus IO minus, which is true because it is a slow step. And then the rate equation can be written as rate K H2O2 times I minus, which is also correct. So that is how we are going to determine. So the best answer in here is C. Then for 30, the enthalpy change of the reaction for the overall reaction is an exothermic process. So based on the mechanism proposed, deduce the energy profile. So in here, because when you have a 3 steps reaction, so when the reaction is 3 steps, you have 3 loops, and it is an exothermic, so reactant must be greater than the product. So the best answer in here will be A. Okay. Okay, then we have 31. Which change alter the activation energy? So adding a suitable catalyst based on the Arrhenius equation where we have ln K is equals to negative A over RT plus ln A, sorry. So in here, catalyst will lower the activation energy, so which is true. Okay, changing the particle size will not, changing the pressure will not, changing the temperature at the reaction which is carried out will not lower the activation energy. However, it can change the rate constant. Okay, it can change the rate constant. Okay, so the best answer in here is A. Number 32, iodine and propanol react accordingly to the following equation. I2 plus CH3COCH3 gives CH3COCH2I plus HI. If the concentration of propanol is increased, keeping the total reaction of volume constant, rate of reaction also increase. What could be the reason for this? So in here, concentration increase, rate of reaction increase. That means there is particles has more energy at a higher concentration. Sorry, the best answer is donkey D, because they said that concentration increase, so you have more particles. Sorry, more collision. More collision. Okay, so the best answer in here is donkey D. Sorry for the mistakes. Okay, so that is for number 32. And then 33, Boltzmann distributions for the hydrogenation of an alkene for the particular temperature is shown below, which will correctly describe the effect of adding nickel to the catalyst. So adding nickel to the catalyst will cause the activation energy to be lower. Okay, so activation energy decrease, correct? So the loop, does it changes or not? So you have this proportion of the molecule does not change. Okay, so the best answer in here is donkey D. Activation energy decrease. C. So it's C. Okay, so when you only add catalyst, the speed of the molecule does not change. Okay, the speed of the molecule does not change. Therefore, the shape will remain the same. However, adding catalyst will lower the activation energy. So in here, let's say if you start from here, maybe after adding catalyst, okay, the shape will be at here. Okay, let's say at here. Okay, so the peak does not shift, but the activation energy is lower. Okay, so the best answer in here is C. Okay, so that is for 33. Then we have 34. In a higher temperature of car engine, nitrogen reacts with oxygen to give nitrogen monoxide according to the equation. The reaction has activation energy EA. Which reaction path diagram could correctly responsible for this? So since this reaction is an endothermic reaction, okay, so the reactant must be lower than the product. Okay, so the best answer in here will be C. Okay. And finally, for 35, a chemical company used catalyst in the chemical process. Company has now decided not to use catalyst but to increase temperature so that the rate equation is the same as when catalyst is used. Which statement about the new condition compared to the original condition is correct? A, activation energy has decreased, which is wrong because adding catalyst, you will provide the activation energy. So activation energy now will not change. Okay. when you increase the temperature, okay, sorry, when you increase the temperature, there will be more successful collision per unit of time. Okay, so the best answer is donkey D. Not A, donkey D. Okay. Okay, so with that, that is for all the 35 objective questions. Sorry for the some of the mistake that I made, and to be honest, I'm not in the best form to present for right now. Okay, because I keep sneezing and it disturb me for a while. However, I hope that it will be able to help you to understand better, okay, on how you are going to tackle for objective question. So if you have any problems, you can leave a comments down to the videos in here, and I'll see you all in our next lesson. Okay, so with that, I end for my presentation for today. Okay, bye.